for the same DCET 2019. The subject is 805 microcontroller. In the previous year, that is in DCET 2019, they asked 7 questions for the same question paper code G. In that, the first question, that is the question number 137, the 805 microcontroller has dash byte ROM on chip. They are given 4 options: 0K, 2K, 4K and the 8K. I will say the question once again. 8051 microcontroller has dash byte ROM on chip. They are given 4 options: 0K, 2K, 4K and the 8K. Before going to answer the question, first we have to note the what is meaning of microcontroller. What is meant by microcontroller? A microcontroller is nothing but a processor or the CPU. But along with CPU, it has inbuilt RAM, ROM, timer bar counter and input-output ports. I will say once again, the microcontroller is nothing but a processor or the CPU. Along with CPU, it has inbuilt RAM, ROM, timer bar counter and IO ports. Okay, this is the family. In that family, the 8051 is the member. 8051 is the member of microcontroller unit. Okay, in every year question, they may ask at least one question regarding the feature of 8051. I have mentioned some of the features. The first feature is the 8-bit CPU. That means the 805 microcontroller will do the operation 8-bit at a time. That means it will do the operation. It may be addition operation, subtraction, multiplication, whatever operation. It will do the operation on 8-bit at a time. The second feature is it has the internal RAM of 128 bytes. Remember 128 because in every year they ask these features only. Okay. The second one is the internal RAM of 128 bytes. The 8051 has internal RAM of 128 bytes. Similarly, the 8051 has internal ROM of 4K, that means 4 kilobytes. So, the right option is third one, that is 4K bytes of on-chip ROM. Similarly, the fourth feature is it has, that means the 8051 has 8-bit stack pointer. That means it has 8-bit stack pointer. What is meant by stack means stack it is the in RAM it is the upper part of the location or the space. This memory space is mainly used by the CPU. This memory space is called as the stack, and it is the upper part of the internal RAM. In internal RAM we have some portion or some space. This space is used by only CPU. This space is called as the stack, and this CPU stores the values in this stack or it retrieves the data from the stack with the help of stack pointer, so that it has 8-bit stack pointer. The next feature is 8-bit program status word. Okay, it has 8-bit program status word. The program status word, it gives the status or it stores the status after doing the calculation. Similarly, it has 16-bit program counter. The 8051 has 16-bit program counter. This program counter holds the address of the next instruction that to be fetched. Okay, and the seventh feature is it has 16-bit data pointer register. That means the data pointer register, it also holds the address of the instruction. And the eighth feature is it has two 16-bit timer bar counter. That means it has two 16-bit timer bar counter, T0 and the T1. These two timer bar counter are of 16-bit, and this timer or counter is mainly used to generate the time delay, or it is used to calculate the or count the pulses. Okay, and the ninth feature is it is a 14-pin DIP IC, dual in line package IC. That means the 8051 has 40 pin. It has 40 pin IC. DIP means in pin diagram we have a pins in both sides. So we call it as the DIP. DIP means dual in line package, means it has pins on both sides. It is a 14 pin IC. Similarly, it has 4 ports. I already said that the 8051 has 40 pin IC. In that it has 4 ports. that is P0, P1, P2 and the P3, and each port has 8 pins, so that it has totally 32 pins, and these pins are used for input output purpose. Okay, it has 4 ports, that is port P0, P1, P2 and P3, and these ports are mainly used for general purpose input output purpose. Okay, and each port has 8 pins, so that 4 port means 32 pins, and these 32 pins are used for input output purpose. And the next feature is it has A resistor, B resistor and R0 to R7 resistor, and each resistors are of 8 bit. Okay, and these resistors are mainly used to move the data from location to location or from resistor to location. We use these resistors, and similarly it has 5 interrupt sources, so that 805 microcontroller has 4K bytes of on-chip ROM. Remember these features.
The question number 138. To access the internal ROM in 8051, the pin number 31 is connected to or is to be. They are given 4 options. The first option is connected to plus 5 volt. The second option is connected to ground. The third option is left open, and the fourth option is connected to 24 volt. Okay, in 8051 there is a 64 kilobyte of program memory, that is a 64 kilobyte of program memory, and this program memory is further classified into internal ROM and the external ROM. Okay, and the internal ROM is of 4 kilobyte and the external ROM is of 60 kilobyte. So there will be a 64 kilobyte of program memory. Okay, and in 8051 the pin number 31, in 8051 microcontroller the pin number 31 is also called as A bar pin, that means external access pin. The pin number 31 is also called as external access pin. Okay, when this external access pin, that is when A bar is connected to plus 5 volt power supply, when A bar is connected to, that is pin number 31 is connected to plus 5 volt power supply, then the program or the code is stored in the internal ROM itself. When A bar, that is external access pin, is connected to plus 5 volt, then the program or the code is stored in the internal ROM itself. So from the above option, the first option is the right option for this question. Okay, similarly when this pin, that is when pin number 31, that is A bar is connected to ground, that is 0 volt, then the program or code is stored in the external ROM. Okay, here the internal ROM is ranging from 0000H to 000FH. Similarly the external ROM is ranging from 1000H to 4FH. I will say the concept once again. The internal ROM is ranging from 0000H to 000FH, and external ROM is ranging from 1000H to 4FH. Okay.
The question number 139. When the 805 microcontroller is reset, then the content of the stack pointer is. They are given 4 options. That is, the first option is 00H, FFH, 0FH and the 07H. I will tell the question once again. When the 805 microcontroller is reset, then the content of the stack pointer is. They are given 4 options: 00H, FFH, 0FH and the 07H. We already know that the 805 microcontroller has 40 pins. Okay, the 805 microcontroller has 40 pins. In that the pin number 9, in that the pin number 9 represents the reset pin. The pin number 9 represents the reset pin. Okay, when you give square pulse, when you give a square pulse to this pin, when you give a square pulse to this pin, then the 805 microcontroller terminates all its activities and become reset. Okay, I will say once again. When we know that the 805 microcontroller has 40 pin IC, in that The pin number 9 represents the reset pin. When you give a square pulse to this pin, then the microcontroller reset all its activities and become reset. So that at reset condition, the stack pointer is set to 07H. When the microcontroller becomes reset, then the stack pointer is set to 07H. Similarly, the program counter is loaded with 0000H. Okay, when the 8051 microcontroller becomes reset, the stack pointer is set to 07H and the program counter is loaded with the value 0000H. So the right option is fourth one, that is 07H. When the 805 microcontroller is reset, the content of the stack pointer is 07H. We know that stack pointer, it is the 8-bit register. Okay, the stack pointer is a 8-bit register. This register is mainly used by the CPU to fetch and receive the data. So okay, the stack pointer, this is the 8-bit register. This register is mainly used by the CPU in order to fetch the data into the stack or retrieve the data from the stack. Okay, what is meant by stack? Stack, it is a part of internal RAM. Okay, and this stack means a space, a memory space. This memory space is mainly used by the CPU to store and retrieve the data, and this function is done by using the stack pointer. By using the stack pointer, CPU fetches the data from the stack and it stores the data in the stack. So the right answer is fourth one, 07H.
The question number 148, the push and pop instruction uses only. They are given 4 options: the register addressing mode, direct addressing mode, the immediate addressing mode, and the fourth one is register indirect addressing mode. The push and pop instructions are mainly used by the CPU to store the data onto the stack, to store or retrieve the data onto the stack, and this push and pop instruction supports only direct addressing mode. So the right option is second one, that is B option is the right option for this question, that is direct addressing mode. And for example, push A, push address of R0, push #12H. These are the illegal instruction because the push instruction does not support register addressing mode. Similarly, the push instruction does not support register indirect addressing mode. Similarly, the push instruction does not support immediate addressing mode. So it only support direct addressing mode, that is push 03H. Here the 03H is the direct address location of the R3 register. Okay, when you use this instruction, that is push 03H, then the content of the R3, it may be 03H or 01H, whatever the content of the R3 is loaded into the stack, that means stored into the stack by incrementing the stack pointer. The content of the R3 is loaded into the stack. Similarly, if we use push 0E0H, then the 0E0H is mainly used for accumulator register. Okay, the 0E0H is the direct address of accumulator register. When you use this instruction, then the content of the accumulator is stored onto the stack. Whatever the content is present in the accumulator register is stored onto the stack by incrementing the stack pointer. Similarly, if you use pop, this pop instruction, if you use pop 03H, then the content of the R3 is loaded from the stack. is loaded from the stack. The content of the content which is present in the stack is loaded into the R3 register. When you use pop instruction, then whatever the content is present onto the stack is loaded into the R3 register. I will say the concept once again. The push instruction is mainly used to store the content of the registers. It may be R0 to R7 general purpose register, or it may be accumulator B register. The content of the registers are stored onto the stack. When you use push instruction, then the content of the registers are stored onto the stack by incrementing the stack pointer. Similarly, the pop instruction is mainly used to store the content in the register from the stack. The pop instruction is mainly used to store the content of the value which is present in the stack into the register. It may be a general purpose register or the accumulator B register. So the push and pop instruction uses only direct addressing mode, because these addressing modes are illegal instructions. So the right option is second one, that is direct addressing mode. The question number 141, the memory type used to access a bit addressable internal data memory in 8051C is, they are given 4 options: code, data, B data and the X data. The 8051 architecture separates program and data. Okay, here they are given 4 areas. The first area is the code area. This code area is mainly used in the program memory. This code area is mainly used in the program memory. The 8051 accesses the program memory by using the code area. By using the code area, the 8051 accesses the program memory. Similarly, data and B data, these are the internal data memory. These are the internal data memory. Internal data memory. This data is the area. The 8051 accesses the internal data memory by using the data. That means the data is the area. Then the 8051 accesses the internal data memory by using the direct addressable internal data memory. That means by using this data area, the 8051 accesses the internal data memory in terms of direct addresses. In terms of direct addresses, the 8051 accesses the internal data memory by using the data area. Similarly, B data, it is also a area accessed by the 8051 into the internal data memory with respect to bit address. Okay, I will say once again, that is the B data is the area which is accessed by the 8051 into the internal data memory by the bitwise. Similarly, X data is the, it is also a area which comes under external data memory, By using this area, the 8051 accesses the external data memory. The code is the area which accesses the program memory by the 8051 microcontroller. Similarly, data and B data are the areas which accesses the internal data memory by the 8051. Okay, but in data area, the 8051 accesses with respect to direct addresses, but in B data, the 8051 accesses with respect to bit addressable. So the right option is third one, that is C option is the right option for this question. The question number 142, the interrupt vector location of a external hardware interrupt 1 is, they are given 4 options. The first option is 0000H, the second one is 0003H, the third option is 0013H, and the fourth option is 001BH. Okay, before going to solve the question, first we have to know the meaning of interrupt. Interrupt is a signal which breaks or disturbs the continuity execution of the processor is called as the interrupt. Okay, consider these are the instructions. Okay, the 8051 microcontroller starts executing the instructions one by one. Okay, when the interrupt signal is raised or when the interrupt signal occurs, then the 8051 microcontroller stops the execution of the instruction, then it jumps to the interrupt vector table. In interrupt vector table we have addresses of ISR. In interrupt vector table we have address of the ISR. ISR means interrupt service routine. Okay, I will say the concept once again, that is the 8051 starts executing the instruction one by one. When an interrupt signal is occurs, then the 8051 microcontroller stops the execution of the instruction, then it jumps to the interrupt vector table. In interrupt vector table we have so many addresses of ISR. ISR means interrupt service routine. This is also a subprogram which is a predefined program which is mainly manufactured by the manufacturer at the manufacturing time. Okay, in interrupt vector table we have addresses of ISR. Suppose consider if external hardware interrupt 1 is occurs. When external hardware interrupt 1 external hardware interrupt 1, it is also a interrupt. When this interrupt occurs, then in interrupt vector table we have a location of the ISR, that is 0013H. Then the 8051 microcontroller jumps to that location, that is 0013H. In this location we have interrupt service routine. Interrupt service routine is also a subprogram which is manufactured by the manufacturer at the manufacturing time. Okay, when the external hardware interrupt 1 interrupt signal is raised, then the 8051 microcontroller jumps to the interrupt vector table. In interrupt vector table we have 0013H location. Then the microcontroller jumps to this location and starts executing the interrupt service routine programs up to RETA instruction. Okay, when the 8051 microcontroller execute RETA instruction, then it comes to the instruction where it was disturbed or stopped. Okay, I will say once again, that is the 8051 starts executing the instruction one by one when external hardware interrupt 1, or it may be other interrupts also. When interrupt signal is raised, then the 8051 microcontroller immediately jumps to the interrupt vector table. In interrupt vector table we have addresses of ISR. Okay, suppose we are considering external hardware interrupt 1 interrupt signal is raised. When this interrupt signal is raised, then the 8051 microcontroller jumps to the interrupt vector table. In this interrupt vector table we have 0013H. Okay, 0013H, that means this interrupt is serviced at this location. Okay, at this location only this interrupt is serviced. Okay, that is 0013H. Then the microcontroller jumps to this location. In this location we have ISR, interrupt service routine, and this interrupt service routine starts to execute up to RETA instruction. It starts to execute. Upon executing the RETA instruction, then it return to the main program where it was halted or it was stopped, and the microcontroller starts to execute the further instructions. So the right option is 0013H. It is the interrupt vector location. That is 0013H is the interrupt vector location when external hardware interrupt signal is raised or occurs. So the third option 0013H. The question number 143, in 8051 for serial data transfer, the timer mode used is, they are given 4 options, timer 0 in mode 1, timer 1 in mode 1, timer 0 in mode 2 and timer 1 in mode 2. Okay, they are given 4 options. The 8051 microcontroller, it uses 2 pins, that is TXD pin and RXD pin. The 8051 microcontroller uses 2 pins, that is TXD pin and the RXD pin. By using these 2 pins, it transfers or receives the data serially. By using these 2 pins, the 8051 microcontroller transfers the data serially as well as it receives the data serially by the peripheral device. Okay, by using the different baud rate. The baud rate is mainly used to indicate the speed of the operation. The baud rate is mainly used to indicate the speed of the operation. Here 9600 baud rate represents per second, it transfers the 9600 bits. Similarly 4800 baud rate represents per second, it transfers 4800 bits. 2400 baud rate represents in 1 second, it transfers 2400 bits. Similarly 1200 baud rate represents in 1 second, it transfers 1200 bits. Okay, the 9600 baud rate its value is stored in the upper byte of the timer 1 register. In timer 1 register we have mainly 2 types, that is TL1 and the TH1. In TH1 the baud rate values are stored. In TH1, that is the higher byte of the timer 1, the baud rate values are stored and these values are auto reloaded. That means that is mode 2. Mode 2 represents 8-bit auto reload timer. That means when these values becomes FFH and it rolls over to 00H, when it rolls over to 00H, then these values are again used in the timer 1, that is a higher byte of the timer 1. So in 8051 for serial data transfer, the timer mode is used is timer 1 in mode 2 because the baud rate values are stored in the higher byte of the timer 1. When these values are rolls over from FFH to 00H, then the initial values are again reloaded into the TH1 register. So we are using mode 2. So the fourth option is the right option for this question.